if you're just joining us, you are in the, this is the Future of Construction webinar series, so you're in the right place if that's what you're looking for. And even if you weren't, welcome, join us. Someone is saying a larger desk and some tools probably. So what we're doing right now, Deanna is back again today, who is the Director of Learning and Interpretation for the Design Museum. And she is sharing the warm-up activity with us right now.
So this is a rapid prototyping activity where the main question that you're trying to solve for with your design is how could you improve your work experience? So your personal kind of workspace. So the way that you're going to do that, you're going to start out with a bullet pointed list of just 10 of the ideas that you think would help improve your work experience. Then you're going to take those 10 ideas, narrow them down to 5 and sketch them out really quick, very fast. They don't have to be perfect, just so that you have an idea of how they would work. And then you are going to take whatever you have around you, cardboard, paper, Post-it notes, tape, and try to build a prototype or a physical representation of the sketch that you made, of your favorite idea. So I have folks sharing some of their ideas here in the Q&A section. So someone's talking, we've talked a lot about bigger space, more desks, and someone's saying, just actually like a small bench. Something very simple that you can place a laptop on top of while still having space to put materials under. So that's a great way to say not everyone needs the same thing. Some people really need a ton of space and some folks really just want something small and focused. So it's all about your individual needs here.
Someone's asking, does it have to be 10 ideas? And I think Deanna today is going to be talking about the design thinking process. So when we are in the ideation phase of the design thinking process, which I think is where we are right now, it is good to come up with as many ideas. Could be crazy, wild ideas as well.
Yeah, what I'll say is it should be 10 ideas. It does not have to be 10 good ideas. It just has to be 10 ideas. And that's the really important part. It's just as much as you can. They can be super silly. They can be completely impossible, like something that you could never have right now. That's fine. Reach for as high as you can. Think of something totally silly, but don't limit yourself just yet.
And so we are just a little bit beyond the top of the hour. So I just want to formally welcome everyone. So this is day 5 of the Future of Construction webinar series. Today we're going to be thinking about design thinking, and also I'm going to be doing a demo for you of Tinkercad as a possibility of a prototyping tool you can use to engage in the design challenge. So my name is Kellyanne Mahoney. I'm a youth program specialist at Autodesk, and I'm so excited today to be joined again by Deanna Navarrete-Rakakis, who is the Director of Learning and Interpretation for the Design Museum. She is situated in Boston, but we will learn today that the Design Museum is everywhere. We are also joined today by Diana Idenshank, who is the president of the ACE Mentor Program. She is situated in Philadelphia, so we are very excited to have some more geographic diversity in our illustrious panel. And she's going to be talking to us today about the ACE Mentor Program so that you might have opportunities to engage with industry professionals in a mentoring capacity as you are working towards the design challenge or even just design challenges in the future. It's a wonderful program, and we are so excited to have Diana here today as well. Deanna is leading the warm-up activity, and Deanna, someone is asking me re-explain.
Yeah, of course. So we're doing a rapid prototyping activity here. So the main question that you're trying to solve for with your design is how could you improve your work experience? So personal to you. And you're going to do that by first making a bullet point of 10 ideas, as wild as you want, as simple as you want, just 10 full ideas. And then from that list, you're going to pick 5 of them and just sketch them very quickly, very messy, no big deal, nothing perfect. Just so you have an idea of how it would look, how it would work. And then you're going to take your favorite idea, or the one that you think you could reasonably build, and choose anything around you. So paper, Post-it notes, construction paper, and build a prototype or a physical representation of what you had as an idea. And just to give you an idea of the kind of ideation that we're seeing, someone has put out an idea of something that stimulates your muscles with electrical pulses so you can exercise while you're lazily working on your laptop, right? Like, is that possible right now? I don't know. But why not? Why should that be an idea, right? Just go as far out as you'd like to.
I love that idea.
Someone's talking about something very reasonable, something that already exists, right? A fabricator, like a laser printer or a 3D print, a laser cutter or a 3D printer would be really great. So just whatever you think you need to make your work better.
I'm assuming some people may be getting hands-on and starting to actually create their prototype today. So we're excited if you're doing that. You might also tell us about it in the question and answer box.
Yeah, feel free to pop your ideas into the Q&A. I'd be happy to share them now.
Deanna, about how much time do you think students will need in order to be able to at least get enough ideas started to engage in the activity today?
I think, the bullet point list of 10 ideas can take 3 minutes, just as fast as possible, just nonstop, just think, and write. The sketches, I'd say spend no more than like 45 seconds per sketch. Just really let yourself do something very quickly and move on. It's not about perfection here. It's just trying to get your ideas on paper. And then the prototyping might take a couple more minutes, depending on how complicated your prototyping can get. So I'd say probably 5 minutes would be enough to take yourself somewhere.
And Deanna today is also going to be talking about different types of prototypes. Oftentimes I think when we hear the word prototype, we think of something that's like really fancy and even sometimes like fully formed, which is actually the opposite of what a prototype is. A prototype could be a sketch that you make on a napkin. It's just a way of communicating. So you have this innovative idea, and it's innovative. The reason why it's innovative is no one's thought about it yet. So sometimes it's hard to communicate this really innovative idea that you have in your head. So the prototype is just a tool for communicating your idea to an audience or maybe to a potential end user so that you can get feedback from them on the idea so that you can continue the iterative prototyping process. So it doesn't need to be perfect, doesn't need to be fully formed at this point. Someone is saying they need to create a wheel, but have no idea where to get one right now. Someone is saying, interesting in how you might use that. I wonder if it'll be some sort of like a pulley system, more organization. If you're still confused, it's okay. We are going to clarify any confusion that you have. So thank you for letting us know. A room within a room, like a collapsible, ooh, I like this, a collapsible cocoon for work so that you can isolate yourself from living space. Later on, I'm actually going to be talking a little bit about how we can use nature as a design partner as we are ideating and thinking of ideas for how to solve a problem. So that is a very interesting concept to me.
So you are making 10 ideas about the question of how could you improve your work experience. So if you are going to improve where it is that you work right now, so your desk, or maybe you don't even have a desk, right? Like maybe you're working off your couch. What would you do to improve your workspace? And you're going to make 10 bullet points of what you could possibly do to improve your workspace, and then sketch 5 of them before moving on to creating some kind of quick physical prototype.
So I'm seeing a lot of dual use ideas too. That's interesting. So someone said, I've seen a treadmill under a tall desk so you can walk while you work. that idea of being able to continue to exercise, even in the current situation that we all find ourselves in right now, is a really interesting idea. So yes, dual use concepts, modularity are really interesting kind of ways to think about this exercise. Eliminating noise or the amount of people in the space. Again, interior spaces, I think, are something that we are all a little bit more focused on right now in terms of how to adapt to working, around other people. I know some of us are in the city that are participating, so we tend to live in, smaller spaces. So, trying to get the most out of the space that you're in, and also, any ways that you can increase the privacy in your space. Yeah, so someone said, are we coming up with ideas in our minds to kind of just sort of, do this exercise to think about how we might solve the problem of space? Yes. But anything that you can do to kind of articulate your ideas by sketching it would be great. Someone's saying a desk extender on the side when you need more space. Someone is talking about using magnetic power. So having magnetic hand pads that are repulsed by the Earth's magnetic energy to help you learn to stay stable while you rollerblade. So that is pretty mind-blowing idea.
Incredible creativity.
Yes.
That's really great. That's a great starting point.
So Deanna, you think that we're ready to move on soon?
Yeah, I think we can definitely get started just to make sure that we stay on time. And of course, you can always keep working on these kind of quick, they're called rapid prototyping exercises whenever you'd like. And you will be able to kind of see the slide again in the recorded session that I'll let you know where all these live in a little while. So thank you so much, everyone, for listing all of your ideas. Are we ready to just kind of hop in and get started?
I think so.
Awesome. Okay, great. So thank you all for joining us for the 5th day of Future of Construction. So today we're going to be talking about design thinking, talk a little bit about mentorship and how you don't have to be designing alone, and then some tools that are possible for creating your prototypes. So just as a reminder, our 2 design challenges this time around. The first is create a model that shows how you would address an issue of environmental justice in your neighborhood or community, and explain how your design solves this problem through, you can use images, words, numbers, a 3D digital model, and or a physical model. Those are all different types of prototypes, by the way. So first one, environmental justice. The second being create a model that shows how you would address an issue of social justice through architecture. So particularly social justice in architecture. And again, explain how your design solves this problem through images, words, numbers, a 3D digital model, and or a physical model. So how are you going to get there, right? There are these awesome challenges. We've talked all week about all the different things that'll help you kind of understand what construction looks like, what is space, what is design, how do you create something that's 2D or 3D in a 2D space, and all of these kinds of questions. And today we're going to talk about design thinking. So I am from Design Museum Everywhere, and one of the things that we really care about is, of course, design thinking and design process. Like, we love to showcase how folks go through that process. And so we are going to go through the steps of the design thinking process. Now, the design thinking process, it's an iterative process, and iterative just means that you do it over and over and over again, right? It's not a one and done type deal. So it's an iterative process that's used to develop creative solutions for problems, which is perfect for what we're talking about, right? We have these challenges and these problems, and we're trying to come up with creative solutions for them. So the design process is split up into these 5 kind of major sections. The first of which is empathize, which we also call research. Then define, where you actually define the issue that you're trying to solve with and kind of figure out what are your constraints and everything else with them. Ideate, which is what you all just did, which is you had an idea and you wrote it down and you tried to come up with as many ideas as possible. prototype, which is when you take those ideas and make them communicatable to people. So through sketching, through building, through digital tools, you create something that you can share with people. And that's the really important part. It has to be somehow shareable so you can test it, right? So you can get feedback and see how it works. And when folks talk about the design thinking process, we tend to see it in this kind of linear way where you do one, then you do the next, then you do the next, then you do the next, and then you're done, except you have to go back and do it all over again because it's iterative, right? You repeat it. It really looks much more like this. So things, you're going from one to the other, and you might be at the define stage, or you might have already made it to the prototype stage, and you realize in your prototyping that, oh, I actually didn't do enough research into like the Earth's magnetic field. Like, is it strong enough to actually work with magnetic hand pads? I have to go back to the research phase and figure that out. Or you're at the ideation stage and you're realizing, oh, I really did not do enough to like create boundaries for myself. So I'm ideating all of these really cool ideas, but I don't think I can actually do any of them. Like, oh no, what am I going to do here? So they all work together, and you're going to jump between them all as you create your creative solutions here, your design interventions to these problems. So we're going to go through each step one at a time and just give a couple of examples of how they work and talk about kind of the main goal of every step. So with empathy and empathize and research, the main goal here is to learn about who you're designing with and how they interact with the problem. So we talked a lot yesterday about when you're talking about issues of environmental justice or of social justice through architecture, you're never going to kind of just like walk into a space you've never been before and like decide that you know everything you need to know and that you are going to miraculously solve all these issues, right? That the important thing about these design challenges is that you involve the community that you're designing with. So instead of designing for communities, you're going to be designing with folks. So you're going to get their input. You're going to actually talk to people. So that means no self-referential design. You're not only designing based on your own thoughts and your own things. You're always going to try to design with others in the community, get feedback. You got to care about people, right? You have to actually care about what they think. So that way, when they're giving you feedback or they're giving you advice or they're telling you about their lives and how it's just so hot in the summer, right? And where they live, there's no trees anywhere and it's so warm. You have to care about them enough to say, that's important. So let's figure out a solution for that. Or again, this is all about talking to people. You have to involve people. You have to talk to people. And that gets a little tough right now, right? When it's much more difficult to actually see people in person in a safe way, but there are tons of ways for us to communicate. So I'd love for folks in the Q&A if you can kind of drop some ideas for ways to ask people questions about their experiences and get feedback from folks that doesn't involve having to see someone in person. Let's see. Online surveys, a Google form, absolutely. Social media is a big one, right? Social media polls, right? Like Instagram has a poll set up in its stories, right? It's already there for you. Question and answer stuff, absolutely. Email, right? Right, kind of, is it a little old fashioned? Maybe. Does it work? Absolutely. Gives people time. YouTube ads, right, yeah, that's a great point. Some of us, when we're watching YouTube, will notice an ad will pop up, and instead of an actual kind of advertisement, what it's saying is it's a survey in there, right? Like, have you heard of these brands before? That's a pretty interesting way to get feedback from folks and do some research. Texting, yeah, just contact people you know. It doesn't always have to be folks that you've never met before. You can text people if you have their number, you can call them if it's safe to set up, calls like this, Zoom calls, and get feedback that way. Absolutely. Love that. Thank you, everyone. So
Deanna, I love all this, and it's making me think back to the future of construction. And just often, sometimes we don't think of like empathy as a skill that is useful in construction work. But in thinking about like Monday, when we talked about the opportunity of better, and just thinking about like, if we're going to be building 13,000 buildings a day in order to meet the demands, population demands by 2050, and all of the people that are going to be moving to cities, what can we do to make the practice of construction even better? So by actually reaching out to people in communities where buildings and infrastructure and roads and rails are being built, in order to not only have less negative impact on the planet, but to make a better world for the people who live on it too.
Yeah, absolutely. And I think there are a lot of ways that designers go about doing that and kind of gathering that information. And I wanted to highlight two of them here. So one of them is kind of what I call the design senses. So when you're going and you're talking to someone and you're trying to figure out how they're interacting with a problem. So you can use you call them they're 5 sentences, but they're not the 5 sentences that maybe you're used to thinking about. But the first thing is like saying, right? Like, what are they actually saying about the situation? Talk to them, ask questions, get answers that way. What is their point of view? So everyone in a community is going to have a very different point of view about something. So thinking about construction, if someone is building a building next to the building that you're currently living in, some folks maybe are gone all day at work and they're not hearing the construction noises, but then you have some people who are staying at home with young kids and they're hearing noises, right? So depending on who they are, their point of view is going to be different about that as well. Hearing, what are they hearing others say about the situation? So not just what they feel, but their community. What are they getting from their community? Because maybe they're going to get information that you're not going to get immediately because you're maybe not part of that community yet, right? Or feeling, how does the situation make them feel? This matters, right? We want to care about people, and that means caring about their feelings. And then doing, how are they actively reacting to the situation? And one way to organize all of that thinking is through something called a journey map. And a journey map I realize I'm missing a slide here, I apologize folks, but a journey map is basically a way to map someone's journey through a task. So you start at one end and you say, let's say the task is something really simple, like how someone completes a homework assignment, right? Something that hopefully everyone here has some kind of experience with. And you say, okay, I'm going to watch this person complete a homework assignment, and I'm going to track how they feel and what they're doing and what they're saying and how they're thinking throughout their journey. So the first phase of that could be just gathering all their materials, getting everything together so they can actually start their homework assignment. The next part might be trying to remember what the assignment even was, right? Like, was that clear? And as you do that, you're going to notice that there are moments where things aren't as perfect or easy as they should be, right? Maybe they forgot to write down their assignment for that day, and now they have no way of knowing. These are the moments where you're going to be able to say as designers, like, oh, that's a moment where I notice this person's frustrated. So let's see if we can find some kind of this creative solution to design for. And what I have up here is at a design museum, we actually have an activity to practice this. So if you're ever interested in doing any kind of journey mapping activity and kind of practicing that, you can go to Design Museum Everywhere and search journey mapping, and you'll get this activity, which also includes like a little, what is this word? Template of a journey map. So feel free to do that. So empathy, again, you're looking to care about people, you're looking to get information, and you're looking to build those relationships so that you can better figure out together with the community you're designing with how you can actually fix these issues. So that is, in a nutshell, empathy and research. Next step, define. The goal of the define stage is to determine the criteria and the constraints of your project. And we'll go into exactly what those two words mean in a moment, I promise. But basically the ways that you can do that are to identify the problems and the opportunities, right? So you've done your research, you did the journey map. Now the definition part is going to be, like I said, finding those friction points. Where are those moments where you can come in with an idea to help make something better? The best way to do that is going to be to ask questions and absorb information, right? Translate all of that research that you just did. You made all of these great surveys, you got all this great information, and now you have to turn them into something you can do. And finally, kind of write and present persuasively. So the definition phase, kind of the last stage of that, is to be able to say, this is the problem I am solving today. Like, this is what we are going to work on, and be able to communicate that clearly. And that's how you'll know that, oh, I do have a good definition of my problem, right? So like I promised, we're going to talk about criteria and constraints. So the criteria are the positive features of a design that are measurable. So these are the things that are like things that you need, right? So if you're thinking about reopening schools, right, in the fall for COVID, some of the criteria there are that's measurable and that's positive is that you kind of need to bring as many students as possible back, or you have to be able to, or I'm trying to think of another one that is not actually a constraint, because there's so many constraints with the idea of bringing students back.
Well, there's actually, Deanna, there's a good example in the question where they were thinking back during the empathy phase, is there a way to minimize the amount of building being built, maximizing the space for people and positively impacting the climate? So I think oftentimes too, when we think about criteria and constraints, one can kind of blend into the other as well.
Absolutely.
And sometimes when we're in the define phase, we might also be thinking about like tools that we could use in order to help us in defining criteria and constraints. One of them that comes to mind, also even thinking back to Jem yesterday and the way that he was able to think in multiple dimensions at once. If you wanted to research the concept of generative design, so we use generative design also in the building industry as well. And it's a way of kind of, it helps, you're collaborating with automation in order to think in multiple dimensions. So you're actually inputting into the computer all of these things that you want. So you might want, you know, thinking about like an environmental issue, you might want to have more, as much volume as you can have with minimal surface area, for example, because, you know, the surface area on modern buildings is like made out of glass, and that's oftentimes expensive. So how can you get the most space as possible, but using, you know, the fewest amount of expensive materials? So I thought that was a good question that someone asked about, even just thinking about like volume and space and impacting the climate.
Yeah, absolutely. So how, yeah. So I think I'm looking at it now. I can see it now. That's a great question that really kind of blends together that idea of criteria and constraints, where our criteria is to have as much people space as possible, as much green space as possible. And the constraint is also like, but you still need to also have enough space for people to be inside the building, right? And so these things are very interconnected. So one of the things that you can kind of think about as you're thinking about your constraints and your criteria, I feel like I am, one second, yeah. Okay, is thinking kind of just like the technical pieces of it. So how is the design going to work? How safe is the design going to be? When you're answering these questions, these are some of the ways that you're going to get some of those ideas, some of those constraints and those criteria. These are two C words that I always mix up. So that way you have a great idea of how they actually work together. So one of my favorite questions here is, do any parts of the design clash or interfere with other parts, right? So when you're thinking about, you know, this question of how do you create a building that has as much people space and outdoor space as possible, those two things are kind of always going to be working together and clashing and interfering. So you want to make sure that you're answering that question for yourself before you move forward with your design. So the next kind of part, once you have an idea of like, what is the problem statement? What is exactly the thing that I'm looking to solve for? And what are my major criteria and my major constraints for it? You can start ideating, right? And that's something that you all did this afternoon. You come up with as many ideas as possible, and you eventually narrow it down to your most effective and possible one. But that's at the end of the ideation phase. The beginning of the ideation phase is as many ideas as possible. Break the rules, generate a lot of ideas. Don't fall in love with the first idea you have, even if it ends up being the best. Sometimes that happens. Sometimes your first idea is just spot on, right? But don't fall in love with it. Come up with as many more as you can. And then make sure that you're collaborating and celebrating each other's ideas. So when you're working in a group or when you're working with folks in a community to design, make sure that if they come up with something, celebrate it. Like, it's a great idea. We don't know until we try it, right? Don't, it's a moment where you're trying to create as much as possible without shutting anyone down. So, and then of course, think and communicate visually. It's a lot easier to communicate an idea sometimes during like with a sketch. It'll be a lot simpler to say, okay, this is what I think this building can look like. And it'll be kind of hard to describe with your words, but just a quick messy sketch will show me the shape and what it looks like and how it fits in the neighborhood in a way that is much simpler than trying to explain to someone like how you place bricks down to create any type of building. So when you're thinking about ideation, there are a lot of questions that you can ask yourself around the making of something. So these are ways for you to not only kind of have one idea, but then come up with so many different types of ideas from your initial kernel. So I'm going to go back to the, because I just find it so fascinating, like the magnetic pads on the ground to help you rollerblade without falling, right? So great initial idea, right? Solid. So how would you actually make it? What do you need? And when you're thinking about what you need, you might be able to think, oh, well, those magnetic pads would be like really, really heavy, probably, right? So is there something else we can use? Like maybe we're not talking about pads, maybe that's too heavy for your hands. Maybe it's actually something that you strap to your waist that's easier to carry, right? Or you ask yourself about the tools that you need in order to accomplish this. So what's actually possible in the time that you have? How much time does it take to make it? What skills are required? Like what are all these things that'll help you kind of narrow down your ideas or come up with more types, more versions of an idea that you already have. Another way to think about it is kind of the market that you're actually creating for. So the community that you're creating with, how visually appealing is this design going to be to them? Because that matters, right? No one wants to use something that's just kind of like drab and boring. You want it to be exciting. How well does this design actually solve the problem for the community that you're working with, right? That's going to make a big difference. Maybe something is a really, really great idea, but it doesn't actually really solve the problem that you put together in the define stage. And so again, what might the expectations be of the folks that you're working with? How long does the design have to last? So maybe you're thinking of creating something that disintegrates, right? Or composts itself in X number of years. Cool, but like how long does it need to actually last for that to be useful for folks? And how easy is it to use and how enjoyable is the design? These are all ways to, again, kind of both create more versions of something and also start to narrow down your ideas as you approach the prototyping phase. The other one that we think about a lot in like professional design spaces is like the business of it, right? We have to be able to actually like pay to build it or to create it. How much, if we're talking about something that we're going to sell, right? How does it compare to other, like if we're creating headphones, how much does it compare to other headphones on the market? Are people going to want to pay for this headphone if it's like so much more expensive? And if that's not going to work, then maybe we have to come up with a different idea with different materials, right? So these are things that it's always really great to think about, but not necessarily something that in this case you have to kind of spend too much time worrying about, but it's worth thinking about as you create your answers. And then this one is a big one, sustainability. What is the impact of this design on the health of the human society or the environment? So if you're creating this idea and your first idea ends up actually creating a lot of waste, okay, what is the second version of your idea? Still the same kind of approach to the solution, but that's more sustainable. How does it avoid the depletion of natural resources? How does it promote coexistence of the biosphere and the human civilization? So again, a great way to create more versions of an idea and then also to start kind of checking things off if you're realizing, you know, that's not going to work. That one was a cool idea at the moment, but here's a better one. It helps you narrow down your focus. And once you do have a narrow focus, you can start prototyping, and you can prototype multiple things. You don't have to go ahead and decide, and we heard this from Jem yesterday, you don't have to only prototype your best or your only idea. You can decide just to see it. You just need to see it in front of you. You need to see what it looks like to see if it's even a good idea to test. So the point of prototyping is to create a representation of your idea that people can interact with, so that way you can actually get feedback and testing. So how do you do this? You make stuff. You create stuff, you make ugly stuff that you do not care about, and you make beautiful things that you do care about, and you learn the tools, right? So it's all about sketching really, really just messy things, creating things out of paper just to get an idea across, just to see if it's even feasible. And then once you're at a point where you're thinking, oh wait, this could really work. This could work for me. you can go ahead and make what we call a high fidelity prototype, something that's a little more cleaned up, a little more polished, so that way you can present it to folks at large. And they're kind of,
oh, sorry, Dan, I didn't want to interrupt you, but the
go for it.
thinking about prototypes too, that you had talked about looks like prototypes and works like prototypes, and those don't necessarily need to be the same thing. So you could have one really pretty prototype that's maybe like a beautiful rendering of what it would look like Jem had showed us yesterday, and then have a separate prototype that could even be words or some sort of like a slideshow or something that actually explains how it works.
Absolutely. And so that's what I'm going into here, is the difference between kind of looks like and works like prototypes. So here we see someone creating a clay model of a car design, an automobile. And that car is not going to run, right? That car is not going to work. It's not going to, not even if like, I think the bottom of the wheel is square. Like, I don't think you could push it to work. But what they're trying to communicate here is the design of how it looks. So this is what it will look like. It's not necessarily worrying too much about how it's actually going to move or work in its own way. That's different from works like, which I don't know, this is actually a prototype for the type of smartwatch that I wear. And you can see here, it's meant to be just an idea of how a watch can work to measure your heartbeat and your heart rate. Right? So this is hopefully not what it's going to look like when it goes to market, or else no one would buy or maybe some people would, but maybe it's not up with the times, these like chunky blue blocks that you carry around with you. But it's a great way to show folks how the technology would work. And you can blend them together and you can do them apart. They don't always have to, you don't always have to do both. And sometimes it's easier to do one or the other depending on what you're trying to accomplish with your design. The last thing is testing. So the last thing you have to do is finally, or I say last thing, but as we talked about, cycles, right? But so you're going to take your prototype, you're going to put it out into the world, and you're going to collect information about how people actually interact with it. So it's all about kind of figuring out how people feel about it. You're going to take feedback and criticism without taking it personally. So share with your groups, share with anyone, share with a friend, say, here's an idea, here's the problem I was trying to solve, here's my prototype, what do you think? Share with the community you're working with, and then be ready to change directions based on the findings, even if it's not things that you thought about or that you necessarily thought would matter. If folks are telling you this is important to us, all the way back to that empathy stage, right? Care about others, care about what they think. And most importantly here is know when to stop. This can go forever and ever and ever and ever and ever. And I think we see it most in kind of software, right? Like when we're talking about laptops, our laptops are always having to update. There's always something new coming on. And that makes sense because this is a thing that you kind of keep using. But if what you're talking about is a built thing, right? Like it's a building, it's something that you're putting out into the environment, at a certain point, you just got to build it. So you have to know when you've done enough testing and feedback to stop. So thank you everyone for listening to all of that. I think those are kind of the really basics of design thinking and how you get through to actually creating your design intervention. Now, I have here the link to where you can find this. You will be able to find this one in hopefully a couple of hours, and all of the things that we've done throughout the whole week. All of the recordings are there. So if you need to go back, listen through something that was said, watch a demonstration again, especially what's coming up next with Kellyanne talking about Tinkercad as a way to do prototyping. You can go to designmuseumeverywhere.org/future of construction, and it will have the videos, and it'll also have next week a form link so that you can actually submit your design prototypes. So the deadline for that would be August 14th, and we can always kind of figure out if that does or doesn't work for folks. Email us, we'll figure it out, let us know. But that's where we're trying to get to, so that way we can, by the next week, put up a digital exhibition of all of your awesome work. So with that, I want to turn it over to Diana, because one of the things that I said right at the beginning, right, when we were talking about empathy, is you design with people, and you don't have to design alone. You shouldn't design alone. And so part of what Diana is going to do is talk to you about this awesome program that links you up with designers in the real world as mentors. So I'm going to turn it over to Diana.
Thank you. I'm going to just get my screen started.
Deanna, could you also share the link in the chat too with everyone? Because that might be an easy way for everybody to access the page too.
Ready? So some of you that are on are maybe part of this program, may have heard of this program, but we wanted to make sure you all heard about this program. So it was fascinating listening to all the ways you design, and I have to tell you, I enjoyed listening to it as well. And if this is a career that you're really interested in, this is a program that you may want to look at. It's called the ACE Mentor Program. And our mission is to engage and support you through mentoring and internships to pursue a career in architecture, engineering, or construction. And our two main goals is we want to create a more diverse, better prepared workforce for the construction industry. But more than anything is we want to make you successful. If this is a career path that you're interested in, we want to assist and guide you in that path with with all the resources available to us to help you become one of our future employees. Our program is free. It's open to any high school student that is interested in attending. And I will tell you that the education goes well beyond a textbook. I believe Kellyanne is the one that just said that this is a program where you're actually going to be in the room. And I say that right now, we probably will not be in the room. We will probably be virtual. But once we get through this craziness, you will be in the room with other students as well as professionals in the industry. So you'll be meeting with architects, engineers, construction managers, trades, interior designers, landscape architects, because we want you to learn the path you're interested in, but we want you to understand the entire industry and where your piece fits into that industry. So you're going to be working with these professionals, and they're going to work with you on various activities and projects. You'll actually be asked what discipline you're interested in, and if architecture is your path, you will actually be working with architects to design real-life projects. Our typical meetings are about 15 sessions, usually 2 hours after school. Boston has a wonderful program that meets at Wentworth Institute of Technology and the Boston Society of Architects. But know that this fall, the program will be mostly virtual. As schools are trying to get a handle on what do we look like, we have really decided that the best thing for us to do is be virtual. We're here for our students. We want to help the students, but the majority of our interaction will be virtual. Other thing that our students are very happy about is we award scholarships. We have awarded over $21 million of scholarships. So if the architecture path is of your interest, you probably know you'll be going to school for 4 to 5 years, and we are here to help you financially. And see, I just wanted to share this with you. When we survey our students, we really hear from our students that by being part of ACE, they have learned a little bit more about the importance of what they're studying in high school, the importance of math, the importance of science. And it also, we hear all the time that when they go to college, that they really feel they are a step above the other individuals entering that discipline. Oops, don't know where. I just want to share with you our map. So depending on where you are in the country, did it share? Oops.
We don't see the map right now, but I bet we will in a second.
Yeah, I don't know what just happened. I kind of clicked in and out. I may have been questioning my internet again. So here's the map of where we are. Here are the dots. So if you're in a certain area, let's use Boston, you would simply click on Massachusetts, and it will tell you all about our Massachusetts affiliates as well as who to contact. The other thing I just wanted to show you quickly is in this new world we're in, we have released our student tools. And what you will see is that we have all kinds of other sessions. So some of you that are on invite for this from us, but here are some other sessions if you're interested in Procore. This is Syracuse University. They're going to talk about going into engineering. Later in the summer, we're going to do an architecture one. But here is a wonderful tool site if you would like to just visit. And the tool site is acementortools.org. When you open that site, oops, I put an S on there and it shouldn't be an S.
Deanna, could you also put that in the chat too? Oh, thank you. You're awesome.
So when you open it up, you'll see students and you'll see all kinds of places for you to go, career paths, student activities, if you're looking for some other great activities, because these two got you so excited about the design activities, come visit us. And with that, you know, acementor.org is where you want to go for the affiliates. The other thing is if you do want to join, you just go to the students and you click here to register. Did any questions come in?
Any questions, anyone? There is one question about the design challenge, and I will answer that when I present.
Okay.
Any other questions for Diana?
I don't want to take up too much of your time, but seriously, if you are interested in this as a career path, this is a program that you truly want to look into because you will meet professionals, you will be able to build a wonderful network for your future, and you will learn the industry inside and out.
I wish I knew about it when I was in high school. So
we hear that all the time.
My daughter will definitely be taking it. Oh, so we have someone saying, I love ACE. And then someone said, how do you sign up for the program, the after school program in particular?
I would go to the affiliate page. I'll type the answer. You want to go to the ACE Mentor page and click on affiliates. And that'll show you where we have affiliates. And you can go to students, and that's where you would register.
That's awesome. Thank you so much, Diana.
Well, if anyone has any questions, Kellyanne knows how to get in touch with me. Shoot her. I'm already a member of ACE before all of this, so I'm just asking, will we continue? Yes, we will continue. We may be virtual, but we will continue, and our goal is by hopefully January, we will be back to the cornerstone of our program, which is the face-to-face meetings.
Awesome. Thank you, Diana.
Thank you. Everyone have a wonderful, wonderful weekend. Thank you for inviting me.
Yes, thank you, Diana. We really appreciated having you here.
Bye-bye.
I'm going to now share my screen and get up the slideshow and move a bunch of windows and get into the next part of the session. So at this point, I just want to acknowledge the time. So we only have 13 minutes left. However, I will be sticking on as long as we need to. I know that a lot of you are really interested in the Tinkercad demonstration, so I am going to be providing that Tinkercad demonstration. However, if you need to hop off early, Deanna has shared with you the link to access the recording later. Honestly, with Tinkercad demonstrations, sometimes it might even be better to, you know, I would love for you to participate live with me, but it also is sometimes nicer to have the recording there so you can pause and kind of tinker around and then watch again. So I will not be offended if you have to hop off. Also, similarly with our panelists, all week they have been so flexible and gracious with their time, answering questions at the end. But again, I won't be at all offended if you need to hop off a little bit early, but I am sticking on and sticking with you till the end, till we finish. So thank you both Deanna and Diana, Deanna and Diana. If you have to hop off early, that's cool. I'd love for you to stick around too, though, if you can. So we're going to get into thinking about the design thinking process. Someone actually asked the question about the design challenge, you know, can it be something more mechanical, or can it be something, or should it be something architectural? We would love for you to really think about, just as Diana just talked about, the architecture, engineering, and construction industry, to think about something that is for the built environment. But that is really the constraint in which we are working with. Maybe you do have some idea for a robot that could integrate into the built environment. So that might be another option as well for you, but we really want you to think about how you could impact the built environment. We talked about on Monday, why is there a special quality to aspects of our built environment that kind of stick with our memories? So just thinking about kind of that permanent nature of things that you make in the built environment is something that we want you to kind of continue with as a thread. So yesterday we learned from Jem, who's a maker, industrial designer. He talked also about how kind of the manufacturing industry can intersect with the construction industry, and how it's continuously doing that in new ways as we move forward into the future of construction. I was so blown away when he was talking just about how he was able to, again, think in that multi-dimensional way. So he's able to think about something that is 3D and just kind of almost like instinctually in his mind translate it into something that's 2D. But that was not instinctual, I think. I think that that was something that even Jem told us yesterday was practice. And on Monday, I know that someone actually asked Suffolk Construction about how they said they really love math and want to study math in college, and they're wondering if that could be a potential pathway into the construction industry. So Suffolk Construction offered a lot of encouragement and support to that student who was interested in math, emphasizing even just kind of the problem-solving nature of math and how that's going to be so important in the future of construction. I was even thinking yesterday with Jem when he was presenting, it was almost like he was combining algebra and geometry at the same time as he was thinking. So thinking about also the convergence of different disciplines and that kind of interdisciplinary thinking is super important in the future of construction. So this is actually an image from Tinkercad. This is a way that you can demonstrate your understanding of Boolean operations through Tinkercad. So this is a union and intersection. And then 2 examples of differences. So just want to throw some math in there. I will tell you that math is not necessarily my comfort space. We talked yesterday about poetry. That's kind of more of my vibe. I was an English teacher and also a journalism major in college, if you're interested. So not construction or technology. But I've always been fascinated by math and fascinated by people who are mathematicians. So this is an example of Fibonacci. And Fibonacci was a famous mathematician who was also very interested in the study of nature and how we can even find patterns in the study of nature that can tell us more about the mathematical universe. So Fibonacci, one of the animals that he studied was rabbits, and he was interested in the mating patterns of rabbits, and also noticed that the pattern of when rabbits were mating. So he had this kind of it was like a mathematical problem of trying to figure out what is the ideal environment for rabbits in order to procreate. And one of the things that he noticed was there was this pattern numbers in which in the first month, if you had 1 pair of rabbits, you would continue to have 1 pair of rabbits in the second month. But in the second month, after the second month, you would then have 2 pairs of rabbits. And then after the third month, you would have 3 pairs of rabbits, and then 5 pairs of rabbits. And this was something that that was later called the Fibonacci sequence. So it's a pattern in numbers that also can be represented visually as well. So when we look at this visual, we can also see that there is a proportional relationship between the shapes that we see and the sizes of the shapes that can also be represented in numbers. So can anyone guess what number would go next, or what number would go in that upper right-hand corner to complete that Fibonacci sequence? Anyone want to take a guess? What number would be put in that upper right green square.
Someone's guessed 5.
Any other guesses?
5, 5.
All right, ding, 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 you are correct. So 5 would be the number in that sequence. So not just mathematicians, but even like designers are interested in the Fibonacci sequence, because when you think about this, the proportionality between the numbers in the sequence, it also kind of is even something that graphic designers are interested in, because it creates this like almost like a beautiful ratio that we call the golden ratio. So we see the golden ratio not only just in design and the way that you might compose, you know, a 2D design, for example, or a painting. We also see it in nature as well. And this is a pattern that recurs in nature. There are other numbers aside from the Fibonacci sequence that we consider to be golden. And one of them is called the golden angle, which is 137.5 degrees. When we are working in Tinkercad later, we can play around with rotation and angles, and that might be a fun one for you to plug in. We see the golden angle in nature as well. So for example, the arrangement of leaves, so the rotation of a leaf around the stem, also tends to be that golden angle, that 137.5. We also tend to see, we have a pattern in your mind, you might see it in other places as well. So this pattern shows up in universal symbols, in culture. A very famous example of the Fibonacci sequence and that spiral that we saw from those numbers is in the Nautilus shell. It's also oftentimes a representation of the Fibonacci sequence and the way that it spirals. So I wanted to stop and pause and think about patterns. So patterns are also important as we think about computation and computational thinking, which we're going to address a little bit in a moment. But I'd like for you to answer in the question and answer, why do you think this pattern recurs in so many places? You might also answer why you think it's important for us to recognize universal patterns existing within our world. Patterns are also super important to architecture as well. For example, when Diana was talking about empathy and some of the research that you might do when you go to place a building in a certain area, some patterns that you might want to analyze could be traffic patterns. It could also just be the simplicity of the pattern in which a human might move around in a space, the pattern of humans liking to have natural light in their space while they are working. So patterns are universal. And I want to know what you're thinking. Why do you think it recurs in so many places? And why is it important for us to recognize?
Someone said it just naturally happened. Maybe we can't explain it yet.
So some things are unexplainable.
Or that things just naturally want to be symmetrical.
Interesting. So the idea of symmetry, and some things naturally want to be symmetrical. Maybe symmetry is just something that is just part of the universe that we can't explain.
They're natural occurrences. They'll always come back.
They'll always come back and they repeat. Any other comments or questions before we move on?
Someone said here, a pattern is a balance.
It's a balance. So I'm thinking back to the yin yang, and I used to teach literature. And one of my favorite critical lenses that I used to like to teach in literature is the archetypal lens. So an archetype is also a pattern. So even in the way that we tell stories, you sometimes will see across different cultures and across different time periods that there are patterns, even in the way that we tell stories, that it's one of those like unexplainable things. Sorry, you can never recover from being an English teacher. Corey from Suffolk Construction was also an English teacher too. So
it's wow,
innovative pathway into the construction industry.
I love that.
Anything else, Deanna?
No, it seems like those are a lot of folks seem to agree that it just happens and it's cool.
Cool, I agree. Patterns are super cool. If you want to explore this further in Tinkercad, this was just a quick design that I made in Tinkercad, thinking about how I could explore those numbers in the Fibonacci sequence. So Tinkercad is a fun place to play around with numbers too. This is also, so I just wanted to quickly share with you an environment within Tinkercad that I think a lot of people maybe aren't familiar with. So within Tinkercad, there is the original 3D editor that I think most people are familiar with. We also have the circuits editor within Tinkercad where you can play with Arduino. I think Jem talked about Arduino a little bit yesterday, or no, Russell did on Tuesday when we were talking about robotics. So we have the circuit simulator and the circuits editor. But the third environment in Tinkercad that is our newest environment is called code blocks. So I just wanted to give you a quick glimpse of code blocks. So code blocks is, you know, if you've ever used Scratch before, for example, it's built upon kind of the same logic and the same sort of blocks that you might use in Scratch, but they do different things. So this is an example from an architect. I did not create this, this model myself. She paid way more attention in math class than I did. So I wish I did pay more attention. You students should too, because math is so cool. And I love the intersection of math and art, and this is really a great example of that intersection. So what she's doing here is she's using code. So you see the code on the left-hand side. So she's using the visual blocks-based code in order to make something in 3D on the work plane. So just wondering, as you're watching this and as the build that is happening on the right-hand side, if there's anything mathematical that you're noticing, or just anything that you're noticing that is a pattern, so something that is repeating. And you can let us know in the question and answer. Anything you're noticing in the math here, or any pattern that you're noticing on the right-hand side?
Someone's saying that the orange code block is repeating.
Yep, so that's a loop. So the orange code block is a loop that's repeating. Anybody have any guesses about what's building here now? What does that look like?
Someone's saying it's making a whirlpool shape.
Yeah, it's very whirly. Like when you're looking at the way that the spheres were arranging themselves on the work plane, you might notice that there was one set that was going one way and one set that was going the other way. Any other guesses about what that was? She titled
a flower, sunflower.
Yeah, so she titled it Phyllotaxis Bowl, which is something that we're going to talk about in a little bit. And it was a sunflower. So if you're actually fascinated by Tinkercad code blocks and maybe want to play around with it this weekend, this is a great place to start, which is these 3 quick kind of activities that will just kind of get you started and oriented. And once you do these, it should be kind of easy for you to figure out, particularly if you've used Scratch before.
And someone has asked for the link to get into Tinkercad, and what would that be, so I can pop it in the chat?
Just tinkercad.com. And
easy peasy.
And then when you get to the Tinkercad landing page, you'll see the 3 environments laid out there for you. So that's code blocks. So that's one way that you could, you know, if you're someone who's in making things, you think in a more computational way, code blocks could be an option for you. It's particularly if you are a high school student who maybe have had some experience in parametric modeling. It has a lot of similarities in the way in which you are modeling and the way that you're thinking about setting up your script. For example, you know, there is, you can play a little bit more with you know, flexibility in the program that you're creating, so you can use variables and all types of other fun things. So that's one option for you. So yes, that was a sunflower. And I just wanted to talk to you a little bit about, you know, some of what was happening in the math there in order to create, it was almost like an optical illusion at a certain point when the sunflower began to build. Even a sunflower, that you can see evidence of the Fibonacci sequence in the way that the florets, which is like the little kind of seed looking things in the head of a sunflower, are arranged. They're actually arranged in spirals that are similar to that Nautilus spiral, the Fibonacci spiral that you see, that you saw earlier. There's 2 sets of spirals. There's one set going in one way, and there's one set going in the other direction. So it's kind of that, when someone said a whirlpool, it's kind of that optical illusion that you see of the 2 spirals going in different directions. And depending on the size of the sunflower, so this is a very small sunflower, so it has 13 sets of spirals going one way and 21 sets of spirals going the other way. If it's a bigger sunflower, can anyone guess maybe what the set of spirals might be? Or anything that you're noticing about these numbers, 13 and 21? What might be the next in that sequence?
Someone's saying odd numbers. Someone's said, is it the Fibonacci sequence?
It is the Fibonacci sequence. I think the next is, it's something, I think it's 3357. I could be totally wrong, but it's something around that, that number. I haven't memorized the Fibonacci sequence yet. I'm sure some of you have. So as the sunflower gets bigger, it's still the number of spirals correlates with the Fibonacci sequence. It's just the numbers get bigger in the sequence. So architects, so getting back to this theme of the future of construction and the AEC industry, some architects are actually use nature, even this example of the sunflower, as an inspiration for architecture. So for example, this is the concept of a building. I believe this is a rendering, so it's a visualization. The building is not there yet, by the architect Sala Masumi. And he used this idea of the way that the sunflower florets are arranged and using that golden angle to angle the balconies on this building. And in doing so, he's solving a problem, a design problem as well. What is the design problem you think he's solving by arranging the balconies in this way? So what do you think the design problem he's trying to solve is through arranging the balconies in the same way as a sunflower's florets are arranged?
Airflow, someone's saying.
Could be, so airflow could be one way. It has to do with kind of the flow of the design. What about like when you're on a balcony, typically when you look up, what do you see?
Reducing sunlight into the building.
Yes, so the idea of arranging the balconies in this way is like, I've been on a balcony before and you look up and it's like another balcony directly above you, so you don't have that access to the sun. The way that he's arranged these balconies is meant to allow a little bit more sunlight, because there's not one balcony directly on the next floor above the other. So that's just one example of how architects can sometimes be inspired by nature. And he's using that concept of phyllotaxis. So phyllotaxis is the arrangement of leaves around the stem of a plant, and they tend to be in that golden angle as well, that 137.5 angle. And one of the reasons why sunflowers actually are arranged in that way, the theory is that they're trying to fit as many seeds as they can as possible in a confined space. And that's the solution that nature has come up with to do that. Someone, I think the day that we talked about robotics, someone said, what's a problem that we might solve with a robot? And someone said to pack a suitcase. So when you're thinking about like packing a suitcase the next time, maybe how can we learn from the head of a sunflower about how sunflowers are able to make the most use of space? So I just wanted to pause and ask this question. So if you had to choose nature or technology, so we're talking a little bit about nature today, but have talked also a lot about technology as in the past. If you could choose one as a design partner, which would you choose and why? So let us know in the question and answer box. I also made this icon too.
Some folks are already saying, can I have both?
Can I have both? I would love to have both too.
Yeah, at least one vote for technology.
Technology, why? And you can just tell us nature or technology too, because it's maybe just interesting to know one or the other. So we have both, we have technology. Anyone choosing nature?
Yes, someone's saying that they would choose specifically a rose because it aesthetically makes good use of space since the petals overlap each other.
Nice.
So, yeah.
And that's the
nature, because you can think of less global warming.
Nature's, yep. So thinking about how we can build for a better planet and use more sustainable design practices.
Yeah. So far, a pretty even split between nature and technology.
Interesting. All right, so we're gonna, for the sake of time, I'm gonna move on, but please continue to participate in the question and answer, and we will make sure that we integrated into the larger discussion. So because I'm an English teacher, I can't really help but include some vocabulary in my lesson. So just in also kind of looping back to that idea of design thinking, this word biophilia, it's a concept that that humans just inherently in our being, kind of like those like patterns in nature that we talked about, that humans just inherently love to be around nature. So when we're thinking about using a design thinking process and integrating empathy as part of our design process, it is kind of a natural go-to to try to design something that mimics nature in some way, because humans are more inclined to like something because it reminds them of nature. That humans just inherently, all humans love to be in nature. So that's the concept of biophilia. The concept of biomorphic, oh sorry, Deanna.
I just wanted to pop in because I think someone is saying something very similar here, that they choose nature because it's tackling many of the same issues that we experience as humans. So it's trying to become as efficient as possible to survive, as do we. And especially when we think about environmental justice, many of the techniques that nature is already using could be applied towards our struggles with the ecosystem.
I just got goosebumps. I continue to be so inspired by your talent, your ability to like communicate with us within these constraints that we've set before you. And I really do, in talking about the future of construction, I'm not being corny when I say that, you are the future of construction. We really think that in tackling these problems that we laid out to you on Monday, that you really are the right generation to kind of energize this movement forward so that we can build better things for all people and make the world a better place. So that's my corny moment, but thank you so much for sharing that. And you had said the idea of, so we see that that root word bio in the start, the prefix of all these words, and it sometimes as humans we think, we use all this technology, we think we are so advanced, but we're all living organisms. So when we're using biomimicry, which is the last word, so biomimicry means that you are taking this like analysis of nature. You're noticing like coral reefs, for example, have this like really amazing systems in order to work within the constraints that they have, like they can't move, for example, very well. So how can we learn from coral reefs how they are able to exist and flourish by using as little resources as possible? So how can we analyze the systems in which coral reefs operate in order to maybe apply that? We could apply that to like our economic system, for example. So biomimicry is a really super cool thing. Biomorphic is a word that we'll talk about a little bit later, because I'm going to show you how you can make a biomorphic shape in Tinkercad. A biomorphic shape is just a shape that is inspired by a living organism. So again, that last word, biomimicry, you are intentionally copying nature. You're not just doing it for aesthetic reasons. Like we all know that, a lot of nature is beautiful and appeals to us visually. It's not just an aesthetic decision. It's also an engineering decision as well, because you're not just learning about the beauty of nature from nature, you're actually looking at how it's structured or engineered in a way in order to promote something like efficiency, for example. So that's biomimicry in all three words. This is actually just one of like my favorite, I love this building, and it's in Montreal, which is one of my favorite cities in the world. This is called Habitat 67. And it was a building that was created by the architect. He's actually quite famous, Moshe Safdie. And he created this actually as a student. I think he had just recently graduated. I don't know if he went to McGill, but he went to one of the universities up in Canada. And he designed this building for the World's Fair, which was happening in Montreal in 1967. And this was meant to be an example of how even back in the 60s, people were thinking about the trend towards urbanization and people living and situating themselves in cities. So how could we have the most beautiful environments to live in within a city? So one of the things that when I look at this and why I think it's beautiful is it makes me think of like cliffs when I look at it, and even makes me think of like the birds that kind of like live inside the little nooks and crannies, the seabirds in cliffs. So one question, but this was in the 1960s. So the concept of biomimicry was not as popular at the time, and it's not clear whether that was what his intention was, to, you know, design a building that looked like sea cliffs. So I'm wondering what you think. Do you think that this is an example of biomimicry? Let us know in the question and answer. So is this Habitat 67 an example of biomimicry, just based on what I told you? Yes or no? And maybe tell us why.
Someone's saying yes because it makes you think of a bush. It's very kind of bumbly and specifically designed. Like there's a lot of choices being made here.
Mm-hmm. Any other responses?
Let's see. I think people are still typing away.
Sorry to engage you in such deep thoughts on a Friday.
Yeah. I think the general consensus is that, yeah, it's probably in some way some kind of biomimicry.
Yeah, I would say yes or no. One of the reasons why I would lean towards perhaps no is because it's not clear. I've actually read a lot about this building, and I can't find anything in which Safdie actually said that he did it inspired by nature. So biomimicry is an intentional decision. So we talk about design, you oftentimes want to think about designing with purpose and being deliberate in our design decisions. And I'm not quite sure whether he actually did intend to mimic this after nature. Therefore, I'm not sure it would be an example of biomimicry. Here's another example. So this is from, I'm really not wonderful at my Spanish pronunciation, even though I studied Spanish in college, but Diana, are you able to help?
Mixco Viejo.
Thank you. Viejo I have, it was the Mixco. And I didn't major in Spanish, but I did go to Spain for a semester. So I got a sobre saliente though.
Love that.
So in looking at this image, do you think that this is actually an example of a biomorphic image?
Someone immediately wrote, dragon!
Yeah, so biomorphic, so it definitely seems to be inspired by like a serpent or, you know, a serpent-like creature. Would this be an example of biophilia? So it definitely looks biomorphic, but is it biophilia? What do you think? And thinking about maybe the purpose of the designer. This is from an ancient structure, so we don't really know so much about the designer's intent.
People are saying maybe and yes, something having to do with a native god.
So I did study art history in college, and one of the concepts that this image might demonstrate is the concept of apotropaic devices. And apotropaic devices are actually employed by cultures. It's kind of an example of one of those archetypes throughout you know, cultures that transcends cultures and times. And apotropaic devices are actually, the purpose of them was to scare people away from building. So you might even also see like the Medusa heads. And we think that this is an example of something that's apotropaic. So you could maybe question whether it's an example of biophilia, because it's not really meant to inspire like the love that we have for nature. There's also, nature also creates kind of a sense of fear within us as well, or at least like a sense of awe that's a little bit scary. So this is another example. So this is a concept. I'm not sure actually if it was built yet, but it was created by the architecture group Exploration Architecture, and it's called the Abalone House. And this is a structure that was inspired by a mollusk shell. So not only was it inspired by the beauty and the shape of the mollusk shell, but also the economy of materials that a mollusk shell employs in order to be able to be as strong as possible, but still its shape allows it to use as few material as possible in order to generate that strength. Is this an example of biomimicry, do you think? Let us know in the question and answer. So is this biomimicry?
As those responses come in, someone has recognized this and said, wait, you showed us how to make this in like 10 seconds on Monday.
Yes, and this is actually what I'm going to demonstrate next in Tinkercad. So yes, this is an example of biomimicry. And again, I just wanted to reinforce that concept that biomimicry isn't just being inspired by the beauty and the aesthetic quality of nature, but also the engineering of nature as well. So I'm going to, in a moment, demonstrate to you how to design this in Tinkercad. And also just because sometimes someone asked on Monday, someone who's familiar with Tinkercad said, how are you able to get the rainbow swash on the gas tank in Tinkercad? Tinkercad doesn't seem to lend itself to be able to make shapes like that. I'm going to show you how I used the scribble tool within Tinkercad, which is fairly new, in order to create more kind of organic shapes. So just really quickly, so the abalone house's roof imitates the geometry of a mollusk shell. So if you're wondering what a mollusk shell is, that's what it is. One of the shapes of a mollusk shell. That's actually a clam shell, I think. Just really quickly before we get into the Tinkercad demonstration, in talking about the concept of biomimicry, it's not just form in nature. Biomimicry also is thinking about how we can use materials from nature in order to design better things. So one example is a quality of nature is bioluminescence, which is when a biological or living entity is able to actually create light through organic processes. So for example, fungi, so like mushrooms, are one example of something that has bioluminescence. And just to give you an example of how designers might use bioluminescence in order to solve a design problem, this is an example of a concept car by Mercedes, in which they were given a design challenge, and one of the constraints was how light it could be, and I forget what the number was in terms of how light the car needed to be. One of the ways that they solved for making the car have less weight to it was to use bioluminescence as part of the lighting of the car. So that's one example. And then just really quickly to review biomimicry, to just give you a few more examples. So fabric designers are interested in studying nature, for example, studying a spider web, and then thinking about how a spider web is made and how we can make stronger fabrics or more durable fabrics with probably fewer materials as well. So that's one example. Turbines a lot of the blades are inspired actually by the fins of aquatic animals like whales. And even glue. So some glues have been inspired by the foot of a gecko. So these are just some examples of biomimicry. I love how someone already talked about how they're inspired by a rose and its beauty and its structure. So keep those ideas in mind, because you might use biomimicry also as a technique as you're thinking about engaging in this design challenge. Even this pattern that I'm showing you, the honeycomb pattern, we think about like efficient use of space, is a pattern that is very inspirational to designers. I just also want to remind you too, when we're thinking about biomimicry and these design challenges, if you want to use biomimicry to solve a problem of environmental justice, I encourage you to continue, as Deanna had talked about earlier, doing more research kind of into some of the problems with the future of making, because you might use that also as an inspiration as you're thinking about solving issues of environmental justice in your community. And also just to reiterate what Deanna said about going out and, to the extent in which you are able to do now, and talk to people about, people who are potential end users of whatever it is that you're designing, or even just stakeholders that, might be someone who might want to fund your design in the future, or, someone who might be impacted by your design, even though they might not necessarily be the end user, like maybe the next door neighbor to the building that you are thinking of constructing. So now, finally, it's time to prototype your idea using Tinkercad. So Deanna has shared with you in the chat the link so that you can join Tinkercad. If you're joining by recording right now too, feel free to pause when you are, at certain points. For this live broadcast, feel free to tinker together. So you can open Tinkercad and maybe have it open in a different window, or you might just watch for now and then later on access the recording to pause. So Tinkercad is it's free, it's web-based. You don't need to download any software in order to use it. Many people think of Tinkercad as like, oh, that's like the 3D design program for children. And I would argue that it's not. Like, it's a really easy way of prototyping. And if you're new to 3D design, it's a great way to get started. But even those that have like PhDs and mechanical and or industrial design, for example, still could use Tinkercad as part of their workflow if they're using this kind of design thinking process of just trying to make the quickest, easiest prototype possible to communicate their idea. So join Tinkercad now if you need. Tinkercad will take like a minute to join if you need to join now, so don't worry. Or you can just follow along. So I'm just going to demonstrate to you how I created the abalone house using Tinkercad. So again, that's not my design, that's the architect's rendering. This is my Tinkercad design. All right, so step one, how I began was I thought about how I could make a biomorphic shape with Scribble. So I'm gonna show you how to do this. So Scribble is when you look at the basic shape, and you should be in the original 3D editor if you're following along. Scribble is one of the shapes that is in the basic shapes panel. So I'm going to show you how I do that. So this is how you start in Tinkercad. So you go to create new design. So I'm clicking that here. And then I'm reaching over for that scribble shape in the basic shapes panel. I'm dragging it out on my work plane, and you'll see when you drag a scribble shape out onto the work plane, it brings you to this cool kind of environment in Scribble where you're allowed to make 2D drawings. So you can see I kind of tried to make that mollusk shape. And then you can, it brings you back to the 3D editor. So there you can extrude that 2D sketch that you made. You can rotate it. So you see me rotating it here. You can also, so what I'm doing here is called Smart Duplicate. So I'm using Command D. I think if you are on a PC, it's Control D, but it's however you use duplicate in like word processing, for example. You would do that in the same commands work in Tinkercad. And what you see me here is actually using Smart Duplicate. So when you use Smart Duplicate, it doesn't just remember the shape that you made. If you do, like, you make a subtle adjustment, like making it smaller, and then changing the rotation, it will remember that too. So all I was doing there is just hitting Command D over and over and over again to make this shape. And then what you see me doing here is once I'm satisfied with how it looks, I draw a box around it and group it together. That arrow that you see that kind of looks more like a teardrop, that's gonna lift it up or down the Z axis to lift it up off the work plane. Now that I have the whole shape grouped together, you can see how I can rotate it. So I wanted to rotate it a little bit. And I think at this point, I'm kind of happy with the biomorphic shape that I made. Oh wait, no, I want to subtract from it. So I want to take that bottom that's hanging off there underneath the work plane. So I'm dragging out a hole. So all of the shapes that you're able to make in Tinkercad, even the scribble shape, you can turn into a hole. So you can subtract from a shape with it. So you can see that I turned that into a hole, and I am using the handles here. You can also type into the boxes as well to change the size, to manipulate the size, but I'm putting that underneath. And then when I'm happy with how it looks, I'm grouping it together. And when you group a solid with a hole, it will subtract from the shape. So now you see I have that nice satisfying flat surface at the bottom, and I have this cool biomorphic shape. So that was a similar technique that I used from when I made the gas tank. I used the Scribble tool. Any questions so far, Deanna?
Yeah, folks were asking if you could kind of show that piece again, or if it's a video. And I think that, yes, it'll be great for folks to kind of come back to this recording and watch it kind of slower and pause as they tinker alongside it.
And that's how I taught myself Tinkercad like right before I joined Autodesk. And I taught myself Tinkercad by just watching videos on YouTube. And that's really the technique that I would use, is watch a video on YouTube, pause it if I didn't understand it, go back and rewind it. So for step 2, you're gonna add 2 or more basic shapes. So I'm gonna show you how to do that now. So you might have your own different scribble shape that you've made. This is just my example. But once you have that nice organic shape, you can start to make it look a little bit more architectural by adding other shapes as well. So you see me, and another really important skill in Tinkercad is to learn how to use the camera controls. So I'm using the view cube there to kind of spin it around. You can also change the color of your shape just like I showed you those code blocks activities, there's also some basic lessons for Tinkercad in the 3D editor that you might want to use. So you see me, I'm grabbing this, this box shape. I'm kind of flattening it out because I'm going to use it as a base for my building. So this will be like kind of the floor of my building. You can move shapes in many ways. You can drag them. It's best, I don't know if I was using a mouse here. I must have. Actually, I might not be because I'm using the view cube, but it's better to use a mouse, but the trackpad is fine too. But it is easier to use a mouse. So you see me, so you can also move shapes by using the arrow keys. So sometimes if I'm making more precise movements, I might use the arrow keys to move something. Sometimes if I want to be more precise, I might type into the boxes to give measurements, or I might just drag out the handle. Another important skill is, I think I do this later, so I won't talk too much about it, but there is okay, so now I'm aligning. I love aligning. So I have like minor OCD tendencies. If you're someone like me, the align tool is super fun because you can group together shapes and make sure that like that organic shape is centered on that base kind of rectangular shape. I'll use the align tool again, I'm sure, because I use it all the time. So now I'm dragging out that half sphere. I want to make like so sometimes like you might see like if you're working from a photo, if you're, you know, inspired by something in real life, you might have to think about like what shapes you can use. Actually, this is kind of the pod sort of like room in the middle. So you see that I'm adding this here, but later when I'm adding the column, sometimes you have to be really creative about how you can make a shape look how you want it to look and kind of what the parameters are of a shape and its flexibility. So what you see me doing here is just kind of trying to make it fit more smoothly inside that exterior shell. So I'm stretching the shape because I'm pulling that top handle up the Z-axis to make it taller. If I wanted to, you'll see me later, so I'm duplicating it. So doing the command D. Here, I'm actually scaling it proportionally. So to do that, you hold down the shift key so that it maintains the same proportions, but it just gets smaller. So if you want to scale something, then just hold down the shift key when you're doing it. And then I'm just trying to see how I can make it fit. So that's kind of some of the fun of using the scribble tool, is if you're not using all right angles, you sometimes have to be, you know, there's a little bit more to do in terms of trying to make the, you know, more normal basic geometry fit into this organic shape. So then you see me duplicating it again. So I'm using the command D. I'm just moving that shape over using the arrow key. I tend to do that after I smart duplicate. And then I'm just using my camera controls to inspect how it looks. So I'm making it wider, so I'm dragging out those handles to make it wider. Again, if you're working with a biomorphic organic shape, it's not going to be as, you know, symmetrical as if you are, if you're using the basic geometry. Yep, so then for the columns, I'm going to use the paraboloid. So I'm going to show that next.
Someone's asked if Tinkercad is accessible on Chromebooks.
Yes, it's highly accessible on Chromebooks, and we actually very recently, we've been working for a while on improving the iPad experience with Tinkercad. So it's very, very usable on the iPad as well. And one of the cool features about using it on an iPad is we have an AR feature in Tinkercad now. So on the iPad, so if you take your iPad outside with your design, you can actually like situate it in a real environment, which lends to fun, you know, architectural designs. So
along those lines, someone's asked here, when they're kind of submitting their final rendering or prototype, do they have to display the already built surrounding environment, since if their model is integrating into that already existing environment?
You don't have to, but I definitely think it would make it interesting if you could figure out ways to put it within the existing environment, and even to use like real geographic information from a map. Like we talked about how in Formit you can use Bing Maps is kind of a better, I love Google Maps too, but Bing Maps is kind of better for extracting that geographic information, because the that's like the street view, or the satellite view rather, is higher resolution, and also it's gives you a perfect bird's eye view, so you can actually get like the, you know, the tops of buildings and extrude them too. So however you want to do it, and I'll remind you of that Format resource after this, but you know, if you want to put a background, I think it gives us a more sense of, you know, it's an object within a space, which is cool. So step 3 is to add a shape that would provide support. My guess is I'm going to choose the paraboloid. I made this a while ago, so I forgot which one it was that I chose. So I'm adding those columns that you see there. And again, so one of the basic lessons in Tinkercad is camera controls, and they're so important. Don't skip over them, because even particularly if you want to 3D print something, sometimes you think two shapes connected, that when you zoom in really close, they didn't connect, and that's going to make your 3D print fail. So you do not need to 3D print your design. You may, if you want to 3D print your design and take a picture of it and share it with the design museum, but that's not necessary. Oh, you see me here shifting from perspective view to orthographic view. I'll sometimes do that using Tinkercad, particularly if I really want to inspect the size of something, or to try to like center something. So that's a nice feature to use, is the orthographic view. And what am I doing now? Oh, so I just wanted to rotate it. Why am I rotating it? I probably had some reason for why I was rotating it. Oh, because I'm flipping it over. I forgot. So the columns are skinnier at the bottom and taller at the top. So you see me using the rotate there to flip it over. Sometimes when I use the rotate tool, I try to zoom in a little bit more because it makes it easier. And when you use the rotate tool, if you want to be more precise in your rotation, you're going to use the outer edges. If you want to be more quick in your rotation, you'd use the inside. So you just see me adjusting the shape here, checking it out, making sure it looks like it would be an actual structural support to the building. Right, and then next, I think I'm dragging out another column. Oops, no, maybe I don't like the way that it looks and I want to move it in. Well, I do know that I want to put glass on the front, so I think part of it is I want to make sure the columns are fully inside. Oh, and then I was duplicating it, so I did a smart duplicate. And I wanted the column to be directly behind the column in the front, but it also needs to connect with that organic shape. So then I'm duplicating it again, so that's a smart duplicate. And I'm making another column. So I do want to have some sense of symmetry, and one way that you can achieve that sense of symmetry is by duplicating shapes. But again, I am combining symmetry with, you know, an organic shape. So you might have to adjust things a little bit. So I think I'm worried here about the column getting lost inside that little pod room there. So I'm changing up my design to make that little room pod smaller so that the column is not clashing with the room structure. So even in Tinkercad, just like design thinking, the process is very iterative. A lot of times I show those like super sped up versions of designs that I make, but you know, oftentimes it's a trial and error process when you're designing. So that I'm using Tinkercad to duplicate again. I'm zooming in to make sure the column is fitting. I'm probably also wanting to check to make sure that it is actually inside the building, because sometimes things look like they're inside, and then when you zoom in, you realize that it might be somewhere else that you didn't think it was. So there are the columns. So hopefully you've added some structural support to your building too. Any questions before we move on to step 4 out of 5? So we're almost there. All right, so step 4 is to add a window or door and make it transparent. So I decided to challenge myself here by also using Scribble to make an organic shape window. So it's not perfect. and this was the second time I did it. So I'm right here, I'm analyzing, and I'm going to probably go to orthographic view. So this is another way that you might want to, reason why you might want to go to orthographic view, because I'm trying to analyze that shape so that I can replicate it in Scribble. So here I am grabbing the Scribble tool, dragging it out. It'll bring me to this cool interface again where I can sketch in 2D. And I'm just trying kind of from memory to draw the shape again at the top and then add this part at the bottom so that it's it can be used as a window. So, and this is how you color. It's fun to actually color in Scribble too. So this tool that you see that kind of looks like a little like splotch or like a little star with a crayon next to it, that's the tool that I'm using to color inside. You can also color with the pen as well, but it's quicker to color with this. And actually this is what I use for the stripes for Rainbow Swash too, because it has an interesting effect. And then I'm just trying to make sure that the bottom is straight as can be in a scribble shape. And then just to kind of fill in the holes. And that's usually the process that I use when I'm coloring in Scribble. So this is also kind of similar to when you're looking at Jem's screen yesterday when he was sharing the Inkscape drawing. You can export in vector files or SVG files in Tinkercad as well. And also you can make really precise shapes if you want to try out code blocks, really precise 2D shapes that lend to really beautiful SVG files. So here I'm flipping this over so that it is perpendicular to the base. So 90 degrees is oftentimes your friend in Tinkercad to make sure things are perpendicular. 180 is another one you might use a lot when you're typing in degrees. And then I'm just moving it back. I think I'm using the arrow keys there. I do remember when I made this that it was not as perfect as the first time. So you see me there, I'm scaling it down. So I was holding the shift key while I'm moving it around, and then I'm not holding the shift key because I want to stretch it and make it smaller and try to make it fit as best as I can. Again, that is one of the constraints of working with organic shapes, is that they don't line up as easily as if you're using, you know, straight up right angles and, you know, basic geometry. So I'm not able to get it perfect in this try for this demonstration. You can see the glass hanging out. I'm not sure if this would pass the engineer's inspection of my design. But I also wanted to show you here, and I continue to fiddle with it to try to make it fit. It's just not gonna fit, but it's okay. I also, once I get it kind of to how I want it to be, and also making sure that it's not behind the columns, I want it in front of the columns. You'll see me taking that solid shape and I'm gonna make it transparent. Oops, and then it got super thick, so I'm just making it thin. Again, using those handles to make it thin. And then just, you know, inspecting it. It's not how I want it to look, but it's okay. I'm just gonna leave it for now. And you can see me now changing it to transparent. So that's a really cool feature in Tinkercad if you're doing something architecturally, is you can make windows by making a shape transparent. One caveat, a warning to that, is you can't, if you want to keep it transparent, you can't group it with the other shapes. So finally, thank you for sticking with us into step 5. I know this is a marathon webinar session, so thank you again. And so we are on step 5, and for step 5, I wanted to just show you really quickly how you could add a person or object for scale. So really when you're designing for the built-in environment, that relationship between the human and the space and the structure and even like the proportions and the ratio of human to the structure is really important. Because sometimes you might make something that like really, like you want it to be awe-inspiring. So like the relationship between the human and the structure is really dramatic. Sometimes you want it to be kind of a more intimate space. So one way that we do that, and even like those like Lego architecture sets my daughter has, there's usually some piece that's like a car or like a little person so that you can show actually how big it is. So I had done a Google search to find copyright-free images to find a silhouette of a human. So that was the process that I used before. When you find images on Google, they will, even if it says it's an SVG, it is going to download as a PNG. So you need to find some way to convert it from PNG to SVG. So there's an online converter that I use that's free. If you just Google PNG SVG converter, you can find that, because you can only import SVGs in terms of images into Tinkercad. Another way that a student was suggesting is, I guess, Google Draw. I don't use Google Draw a lot, but you can export from, so if you import an image that's a JPEG or a PNG into Google Draw, you can then export it as an SVG as well. That is a tip from a student. So what you see me doing here is just kind of changing the degree of it. When you're importing an image, an SVG image into Tinkercad, it will prompt you, and you might want to change this. I oftentimes just as a default change the scale from 100 to 10, because otherwise it might yell at you and tell you that the file is too big. So I think you saw me doing that there. So I'm zooming in, I'm adding my person. I kind of just want to show that's kind of like the entrance to the building. So I just want to show like the relationship between the human to the entrance of the building. I think I made my people smaller and the scale smaller. I think with the abalone house, it's actually a little bit different. So changing up the design. So making that bigger. There we go. I have a little person. And I'm going to actually just show you, I'm going to add another person. Oh, I wanted to put this person actually inside, I think, to show them inside behind the glass. And then I added another person. So you'll be able to see that process of importing an SVG again, because I do add another person to the design. And you might want to do that for scale, particularly in thinking about perspective, is to have like two images that could show scale, because one might be further back and one might be further front. And also just kind of thinking about the relationship between the interior of the building and the exterior of the building. So I think I am moving this person inside. Yep. And then again, shifting to, so orthographic view is sometimes good to see if your people are floating or there are objects that are floating. And again, if you don't want to stretch it, but just kind of move something along the Z-axis to make it up above the work plane or below the work plane, you use that kind of like teardrop looking arrow shape to do it. So there we go. I am just getting so fussy here. This is why I think I sometimes speed up. Oh, I think I just wanted to tilt them a little bit. I think I put them at a 45-degree angle because that's kind of a nice angle for capturing screenshots later of your design, which I love to do. So I just want to show you really quickly again, just to review too, to import the SVG. It's very simple. Oh, what's happening there? Oh, I messed up with the glass. And again, to find SVGs, if you Google in Google Images, you know, I did silhouette because you want an SVG, so it's just two colors, you know, black and white, or basically like black and clear, or one color and not a color. So you might type in SVG in your Google search, and again, try to use copyright-free images. All right, so I actually had an image in my part collection. So that's another thing that you can do, is create a part of the image, so then it just exists in your basic shape. So if I want to grab this person again and not go through that whole process, you can just save it as a part and add it. And then, you know, then you see me dragging out, so you can drag out other people as well. So here I drag out another person and scale it down. Right, so you get it, I think. So let's move on. All right, so just to wrap up, and Deanna, I just want to give you a sense, because we're at like 47 minutes over right now. So Deanna, if you need to take off, let me know. I was just gonna wrap up like in 5 minutes, I promise. And those of you who are sticking around, like I wish I could give you a real life high five, but I'm high-fiving you in spirit right now because it's so cool that you've stuck around for this session. And again, if you're watching it via recording, that's great too. So just thinking about like, you might, in your ideation phase of design thinking in response to the challenge, you might find inspiration in nature. In thinking about the design thinking process, I'm just going to pause here just for a moment. So if you are watching this via recording, you might, screenshot this just to help you in your thinking. So thinking about who the end user is, what's happening, and also just kind of what matters most. So maybe it's the idea of, being expressive, or maybe it's the idea of inclusion or accessibility or, sustainability. So really always making sure that you, even as you're iterating, you're always still thinking about that perception and that idea that is most important to the end user. This is just the criteria and constraints graphic that Deanna had showed earlier. I just wanted to show all of them together in case you want to use these questions, as you're refining your thinking or even during the ideation process as well. I know that Deanna showed this within the context of the define phase. This is also just a great example of how you can apply an engineering mindset to a design thinking process as well. Particularly, it's like you have like you might have your design thinking hat where it's like so many crazy ideas and more ideas the better, and then it's sometimes fun to put on that engineer hat or that editor hat to then use that to refine your idea. So this might be something that you might want to like screenshot and refer to later as you're asking yourself questions about your design. Oh, really quickly, I just wanted to show you this cute video. So if you really loved Jen's rendering yesterday, this is how you can go from Tinkercad. Actually, it's easier to go from Tinkercad to Fusion because there's a send to button. But this is how you can take a design, bring it into Fusion 360, which is free for students and educators. And this is how he was applying materials or changing the physical appearance of his design by applying physical materials in order to make it more photorealistic. So this is the workflow that he likely used, although he was going from Inkscape into Fusion 360. And there is a send to button now from Tinkercad into Fusion where you can just upload, you want to upload your OBJ file into Fusion, not an STL file, because the OBJ will make it easier to color if that's the purpose of why you are using Fusion. And you can put like cool background images too. Just want to show you that quickly. This is also a design from a student in Portland, Maine, who was one of the winners of our Make It Real contest. He designed, it was a tidally influenced generator, and he designed it in Fusion 360. And then you can see that he took that in rendered, which is basically like you're coloring in 3D and applying physical materials to the surfaces of your designs, and then you actually render it by taking pictures of it. So this is just an example of, you don't have to render your image, but if you wanted to, this is an example of how he also called out key features of his design in a very simple visual way. So if you're wondering like, what would my design ultimately look like that I'm submitting to the design museum, this could be, one way of showing it. So this is just really quickly, if you want to download software for free from Autodesk. So if you want to use a more professional or a more complex tool than Tinkercad for your design, this is how you could download Fusion 360. If you use this URL, it will take you to where you can get your free download. And you don't want to do the 30-day trial, you want to get your student education license. I also just wanted to remind you too of this format tutorial that I showed you on Monday. If you are interested in Format, which is our conceptual architecture design tool, this would be a useful tutorial for you to do. So this is the Farnsworth house, and someone had asked about having a background. The background came from real geographic information that is publicly accessible to you, and this tutorial will show you how they did it. So I think that's everything. Wow, guys, I'm still just so impressed that you're still here. Thank you, Deanna, for
Absolutely.
sticking along for the long slog. I learned so much from you, Deanna, so I just want to say thank you for your help in taking us through the design thinking process. Anything you want to share before we sign off?
No, just we're really excited to see all of your designs. And again, they can be, you know, as simple as a sketch or as cool as something that's built or as polished as something that's rendered, right? It's totally up to you. How it is that you want to communicate your ideas. We're just excited to see them on that link.
Could they share a poem too, Deanna?
I mean, why not? Why not also a poem? I'd say also a poem, not just a poem, but also a poem.
And when we're thinking about a model, it's multi-dimension. So maybe it's, you know, a digital, you know, 3D design, and then maybe you're including some text as well. So we are so excited to see what you make. And again, thank you for joining us for the future of construction. And please stay in touch and let us know what the result is of this long, wonderful process. And we're so excited to see your designs. All right, so thank you. Signing off for now. Have a wonderful weekend. Take care.
Bye, folks.
Bye.